Hello everyone, this is Madhuri, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today we are going to discuss the types of DC motors as part of our DC machines course. So previous classes we have discussed about the working principle of DC motor, and also we have discussed about the back EMF and its significance. Today in this class we are going to discuss about the types of DC motors, what are the various types of DC motors based upon the connection of windings, and what are the respective excitations given to the different types of DC motors, what are the respective current equations, voltage equations and power equations of all the different types of DC motors are seen in today's class. We are going to discuss about the types of DC motors. So in our previous classes we have discussed about the types of generators. So in the same way we are now going to discuss the types of DC motors. So in DC motor or a direct current motor is named according to the connection of your field winding and the armature winding. We basically have two windings, one in the field and the other in the armature. Based on the connection of these two windings in the motor, the motors are classified into basically two types: separately excited and self-excited. So separately excited DC motor means your field winding is separately excited by a DC source. So this separate excitation of your field winding by a DC source is nothing but called as, this kind of motor is called as separately excited DC motor. Self-excited DC motor, the excitation is given by the current within the machine itself or within the motor itself. Such kind of motors are called as self-excited DC motors. So again, there is a sub-classification of self-excited DC motors. We see the kind of windings based on the connection of windings of both the field and armature. If both the field winding and the armature winding are connected in series, then it is called as series motor. If they are connected in parallel, then it is called as shunt motor. If both series winding and shunt winding are connected accordingly, if we have the presence of both the windings accordingly, we have compound wound motor. So this compound wound motor is again divided into two types: long shunt compound motor and short shunt compound motor. So this is one more classification of compound motors. So basically we have two kinds, separately excited and self-excited, based on the excitation given to the field windings and based on the connections of the field windings and armature windings. We have shunt motor, series motor and the compound motor. First we are going to discuss about the separately excited DC motor. Separately excited DC motor, the name itself signifies that some part of your motor is excited separately. So here the field coils or the field windings are energized by a separate DC source. As shown in the figure, we can see that this DC supply is given to the field windings of the motor. So field windings, we know that it is situated on the poles of your motor in the stator of the DC motor. So your armature is connected to the load of the motor. So whenever a separate excitation is given to the field coils, so that kind of motor is called as separately excited DC motor. So the speed of this particular motor will always depend upon the supply voltage. So this supply voltage is indirectly depend on the field current. So DC motor speed, the separately excited DC motor speed always depends upon the supply voltage which is given to the field winding. So the magnetic flux which is set up in the field winding will be interlinked with the field current which is given by the supply voltage. However, we find a very rare applications of separately excited DC motor because of its only disadvantage that it requires a separate source for its excitation. So that's why we rarely use this separately excited DC motors. Moving on to the next type, self-excited DC motor. Name implies self-excitation. So the current in the windings is supplied by the machine or the motor itself. When the current required by the armature conductors is supplied by the machine or the motor itself, then that kind of motors are called as self-excited DC motors. In that, we see the first category as shunt wound motor or shunt motor, simply called as. So this is the most common type of DC motors. Here the winding, that is nothing but the field winding or the shunt field winding. We can say it as shunt field winding. Shunt field winding is connected parallel to your armature of your motor. So whenever an armature is connected in parallel to the shunt field winding in the stator, so such kind of motors are called as shunt motors or shunt wound motors. Here you can see a DC excitation is given to the armature conductors with the help of a DC supply. So here this supply will drive a current, source current IS. So this current will get divided into this branch and this branch. So we can see that IS or the line current, we can also call as this IS as a line current. The incoming current at this particular node, consider this node as A. So at this particular node, the incoming currents is equals to the sum of outgoing currents according to Kirchhoff's current law. So we can see the line current which is coming towards this particular armature or this particular node will be divided into armature current and the shunt field current. So this is the current equation for this motor. So we can see that I is equals to IA plus ISH, which is nothing but I is nothing but the input line current, IA is nothing but the armature current, ISH is nothing but the shunt field current. So voltage equations written by Kirchhoff's law. So we are going to write the voltage across. So if you see the circuit, we can see that in parallel branches the voltage is same. So voltage which is applied by the terminals, across the terminals. So when we see the voltage across this shunt part of the machine, we can give it as the current flowing in this shunt part, which is nothing but ISH, multiplied by the resistance of the field winding, RSH. So this is the voltage which appears across this shunt field winding in the DC shunt motor. So this is the voltage equation which is given across the shunt winding. So the voltage equation across the armature is given as, we know that a back EMF is generated in the armature and also there will be a drop called as IA-RA drop. RA is nothing but the resistance of armature conductors. So along with back EMF, we also have IA-RA drop. So the voltage across this armature is given as V is equals to E, which is nothing but the back EMF EB plus IA-RA drop. That is nothing but the drop across the armature windings. These are the two voltage equations of the armature voltage equation and the shunt field voltage equation and the current of the DC shunt motor. So whenever we see the power input, we know that electrical input is the input to your motor. We know that a mechanical power will be developed in the motor and plus the losses which are occurred in the armature and the losses in the field. Together is nothing but, altogether this is nothing but the output power of the motor. So power input, when we equate the input power with the output power, we get the input power as the supplied DC voltage multiplied by the current, line current I, which is nothing but the mechanical power which is developed in the motor or in the rotating part of the machine, and the drop across or the loss which occurred in the armature and the loss which occurred in the shunt field winding. So altogether we can write it as electrical input is equals to mechanical output plus the losses in both armature and the field. So whenever we write the equation for mechanical power developed, we can bring this term to this side and we can write this equation, entire equation. So we can also say that this particular PM is nothing but the back EMF EB multiplied by the armature current. As we know that armature is responsible for giving us the mechanical output. So the mechanical power which is developed in the armature is given by the back EMF multiplied by the current IA. Moving on to the next kind of motor, it is nothing but the series wound motor. So in series wound motor, the name itself indicates that both your field winding and the armature winding will be connected in series. That is nothing but the field winding and the armature winding will be in series. So now we can see that both are connected in series. We know that in series the current remains same. So your line current will be equals to the armature current will be equals to the series field current. So a single current will be flowing from the supply to the armature in the form of a closed loop. So this is the current equation according to KCL. So only one current will be flowing in the series circuit. So we can equate the line current to the series field winding and the armature current. So where ISE is the series field current and IA is the armature current. So from this we can write the voltage equation for the circuit as, or for the motor as, V is equals to EB plus I into RA plus RSC. So everywhere when we write the motor equation, we also should remember there will be the drop across brushes also. As though it is very negligible quantity, but we need to add the brush drop also in the voltage equations. Again, writing the power equation for the DC series motor, we can see that V into I is the electrical input given to the motor. EB into IA is nothing but the mechanical output developed in the motor, and I, the single current which is flowing in the series motor, multiplied by the sum of resistances of both the armature and series field, will give the drop across the motor or the loss which occurred in the both the windings of motor. So this is the losses in the windings, and apart from this we'll also have the brush drop or the loss occurred near the brushes. Though it is a very small quantity, small amount of drop occurs across the brushes, so we also need to consider it. So power input will be again equals to the mechanical power developed and the losses in the armature and the field. So from here the mechanical power developed will be again EB into IA, the back EMF which is developed in the armature conductors, multiplied by the current which is flowing in the entire series circuit. So comparing the equations 9 and 10, we get the losses. This we can write as I square RSC. So electrical input is equals to mechanical output plus the losses occurring in both the armature winding and the shunt series field winding. This is about the series motor and the respective voltage, current and the power equations. Moving on to the compound wound motor. So compound wound motor, we can see that there will be presence of the field winding both in series path and the shunt path. So we have the series connection of field winding and also shunt connection of field winding to the armature of your motor. So whenever an excitation is given to the motor, so whenever this shunt winding is completely connected across the combination of series field winding and the armature, such kind of compound motor is called as long shunt compound motor. So whatever you see in the figure now is nothing but a long shunt compound motor. So whenever you see a shunt field winding only connected across the armature of your motor, so then this kind of winding or this kind of motor is called as short shunt compound motor. So this is one classification of compound wound motors based upon the connection of shunt field winding across the combination of series field winding and the armature. So whenever we see a field winding which is connected across the combination of series field winding and the armature, we call it as long shunt compound wound motor. Whenever we see a field winding which is only connected across the armature, we call it as a short shunt compound wound motor. So this is about the one type of classification of compound wound motors. We also have other kind of classification. So as discussed just now, this is nothing but long shunt and short shunt. We also have differentially compound wound motor and cumulative compound wound motor. In this compound wound motor, the flux produced due to the shunt field winding reduces the effect of main series winding. That means the flux which is produced by the shunt field winding will oppose the flux which is produced by the series field winding. That means they will oppose each other. If the flux produced by the shunt field winding enhances or aids the effect of series field winding, then that kind of motor is called as cumulative compound wound motor. So we can see here in a cumulative compound wound motor, we have the resultant flux. So if the resultant flux of shunt field winding and series field winding, if they aid with each other or if they enhance in the compound wound motor, then that kind of compound wound motor is called as cumulative compound wound motor. In a differentially compound wound motor, the flux produced by series field winding is opposite to the flux produced by the shunt field winding. So in such case, there is opposition between the two fluxes generated by the shunt field winding and the series field winding. So in such kind of motors where there is opposition of flux between the shunt field winding and the series field winding is called as a differential compound wound motor. So this is the basic classification of all the motors, that is in the DC motors. So this is about the types of DC motors which we have discussed in today's class. So conclusion of today's class. So we have basically discussed about all the different classification of DC motors. First, we have discussed about the separately excited DC motor. Then we have discussed about the self-excited DC motors. So basically separately excited DC motors which requires the separate excitation, self-excited DC motor which will run with the current generated in its respective armature. So based on this, we have seen the classification of shunt and series. We have also seen the voltage, current and the power equations in these motors. So in the self-excited machine, we also seen the compound motor classification also. Based on the connection of shunt field winding and series field winding, we have seen the long shunt compound wound motor, that is when the field winding is connected across the combination of series field winding and armature together, it is called as long shunt. When the field winding is only connected across the armature, we have seen about the short shunt. Based on the opposition of and aiding of the flux in both the series field windings and shunt field windings, we have seen the cumulative compound wound motors and the differential compound motor, which is one more classification of the compound wound motors in DC motors. So this is about the types of motors which we have discussed in today's class and the respective voltage, current and power equations. Thank you.